So we were able to calculate polar bonds, but to have a polar molecule, you actually need a little bit more. To have a polar molecule, you need to have polar bonds, but you also need to have a situation where the dipoles don't cancel. We saw in HCl, there was no other bond. So all you needed was one polar bond, and there was no other bond. It was automatically polar. That was a simple case. Carbon dioxide, now you had polar bonds, but you have the dipoles are going in opposite directions, so they cancel. And so this makes you a nonpolar molecule, right? And so we gave you a simple kind of situation to decide if the dipoles could cancel. Dipoles cancel when you have a symmetrical molecule, which is if you have a linear molecule or a trigonal planar molecule or a tetrahedral. Those are symmetrical molecules. And so if you happen to have all the dipole values be the same, then they can cancel. So we saw, here's a situation where I have a symmetrical molecule, but I only had one dipole, right? So this one's linear, but it happens to be polar. Or we saw carbon tetrachloride has polar bonds, but they're all the same value. They're all going outward, and you have a symmetrical molecule. So that one was also a case where the dipoles cancel. But we could have a symmetrical molecule like this one, and if the dipole values are different, then they can't cancel, and you will have a polar molecule. This was showing an example of the dipoles canceling in a trigonal planar molecule. We could have a hydrogen on the top, right? And two fluorines. And now, so hydrogen's 2.2 and boron is 2.0. So this bond here is 0.2, which is nonpolar. So I would have very polar bond down this way, but there would be no bond on the top to oppose it. And so there would be a net dipole, in this case, going downward. What about BH3? All bonds are 0.2. It's my analysis of this molecule here. What would we say?
It's nonpolar.
It's nonpolar. So it's symmetrical, but it fails on step one. You have to, there's no polar bonds, right? So this one fails on step one. This one fails on step two over here. This one is a symmetrical molecule, but the dipoles cancel, right? This one over here is a polar molecule. So it's symmetrical, but the dipoles don't cancel. You have a dipole, you have two dipoles going down, but you don't have a dipole going up to oppose it, right?